Hi, this is S.N. Mushkina Banu from CSE branch. Today my topic is gas chromatography. Today we are learning about gas chromatography, how it works. What are we are discussing? The contents of gas chromatography are first introduction and some basic principle and applications of gas chromatography. Gas chromatography. What is gas chromatography? Gas chromatography is special form of chromatography. It consists of gas solid chromatography GSC and gas liquid chromatography GLC. Gas chromatography is special form of chromatography. It has two types of gas chromatographies. One is gas solid chromatography and another one is gas liquid chromatography. In both types, gas is used as mobile phase and either solid or liquid is used as stationary phase. In both types means in gas solid chromatography and in gas liquid chromatography. Gas is used as mobile phase and either solid or liquid is used as stationary phase. This is the figure of gas chromatography working. First, the gas chromatography consists of sample. A sample is injected into a injector port and the gas flows from regulator to column and the waste part is collected at the detector and goes to the computer data analysis. The basic principle of gas chromatography. The principle of separation in GLC is partition, means to separate, and gas is used as mobile phase and liquid which is coated onto a solid support is used as stationary phase. The mixture of the components to be separated is converted into vapor and mixed with gases mobile phase. The component which is more soluble in the stationary phase travels slower and evaluated later. The component which is less soluble in the stationary phase travels faster and evaluated out first. The component which is more soluble in stationary phase travels slower and evaluated later. The component which is less soluble in the stationary phase will travel faster and evaluated out first. No two components have the same partition coefficient for fixed combination of stationary phase and mobile phase and other conditions. Hence, the components are separated according to their partition coefficient. Applications of gas chromatography. Gas chromatography is used in qualitative analysis. By checking the quality of a material or a liquid, we use gas chromatography and checking of the purity of the compound. The percentage of impurities may also be calculated from gas chromatography. Multi-component analysis or determination of mixture of drugs. We use chromatography to, to, to calculate the percentage of impurities, the compound is pure or not. We can use gas chromatography. Isolation and identification of mixture of components like amino acids, plant extracts, volatile oils, etc. in mixture of components like amino acids. In amino acids, there are mixture of components there. So, We can use the gas chromatography to calculate the components which are there, and in plant extracts we calculate the which is not impurity and purity of plant extracts, and also volatile oils and etc. Isolation and identification of drugs and metabolites in urine, plasma serum, etc. can be carried out. In some of pharmaceutical applications, we use gas chromatography. Conclusion. Finally, I conclude that gas chromatography is one of the most important tools in chemistry because of its simplicity, sensitivity, and effectiveness in separating components of mixtures. It is widely used for quantitative and qualitative analysis of mixtures and for the purification of compounds. Thank you for giving this wonderful opportunity. Have a nice day.